So we are going to continue looking at inductive and deductive reasoning. Now this is going to be part 2. I like to piece these videos into smaller chunks. So the first one was about just over 13 minutes long, and this one I try to keep around the same amount of time, less than 15 minutes. I like that because it gives you kind of a natural pausing point. I know watching these in a row can be kind of time consuming and taxing sometimes. You can pause all that you want, but sometimes it's nice to have like that little, I've watched 15 minutes and it's time for me to take a break. And so that's why I do this. That's the method to my madness. But now we're going to continue looking at examples of inductive and deductive reasoning. So example 2, we're going to prove false by using inductive reasoning, which just means that we need to find one counterexample. Now, there may be many, and I will let you know there are plenty for the first one, but there might be more than one counterexample, but all we need to do is to provide one counterexample to show that these are false. So, no singers appear in movies. Hello, Beyonce in Dreamgirls. Jennifer Hudson in Dreamgirls. The Beatles had movies. So if Beyonce and Jennifer Hudson are not your music that you listen to, you can think of other examples. The Beatles had like A Hard Day's Night, so they were in movies. So we can find many examples that proves this false, but we just need one. So I picked Beyonce and Dreamgirls. If a number is multiplied by itself, the result is even. Okay, so all we need to find is a number that when I multiply it by itself, the result is even. So we can think of examples that make this true. I'll do those in blue. 2 times 2 is 4. That's true. A number that's multiplied by itself and it gave me an even number. Cool. I might think that that's always true. But wait. When I do 3 times 3, that equals 9. 9 is not even. So this is my counterexample. I could have also used 7 times 7. I could have used 1 times 1. Any number times itself that did not give me an even number would count as a counterexample to that statement. Okay, so extra. All 4-sided figures have right angles. I could think of, what about a parallelogram? These angles are not right angles. So, a parallelogram is an example of a 4-sided figure that does not have right angles. It could if it was a rectangle, but that's a special parallelogram. Okay? If I just have a parallelogram that does not have right angles, that gives me a counterexample to that statement. Then if a number is odd, then it ends in 5. Well, we can think of any odd number that does not end in 5, and that tells me I have a counterexample. So 19, 21, 37, any odd number that doesn't end in 5 would be a counterexample. Now for this next example, we're going to use deductive reasoning to draw a conclusion. So we have statements, and then we're going to draw a conclusion. I'm just going to do the first couple of these because I think you'll get the gist of it and you'll be able to figure out the rest on your own. So, all dogs bark. My dog's name is Hank. My conclusion is, since Hank is a dog, then Hank barks. Okay? All math classes are enlightening. I hope you feel that way. This is a math class. So this class is enlightening. Exclamation point. All right. All students do laundry on Saturdays. Joe is a student. Today is Saturday. So from this information, I can conclude that Joe will do laundry today. Okay, and I think you get the point and can do the following examples. Okay, example 4. Was inductive or deductive reasoning used? So, if we take specific cases and then make a generalization, that gives us inductive reasoning. If we have general statements and can come up with a come up with a specific conclusion, then we've used deductive reasoning. So Mike, Dan, Marie, and Ange smoked and got lung cancer. Therefore, everyone who smokes gets lung cancer. They have 1, 2, 3, 4 examples and then came up with a conclusion. So 4 specific examples, came up with a conclusion. This would be inductive reasoning. Remember, we would just need to find one person who smoked and did not get lung cancer to prove that false. Fresh fruit costs more in the winter. This is January. These fresh strawberries cost more. So you're taking specific true cases and coming up with a general conclusion. That is deductive reasoning. Every coach must know his sport well. John Madden was a football coach. John Madden knows football well. That is deductive reasoning. 3 is prime. 5 is prime. 7 is prime. All odds are prime. So this gives me 3 specific cases, and then I come up with a general conclusion. That is inductive reasoning. We look for a pattern in that, and then we come up with a conclusion from the pattern. Now, remember, this does not necessarily have to be true, and I can actually prove this false because I can have a counter example that shows me that this is false. My counter example is 9. 9 is odd, but 9 is not prime because it has more factors than just one in itself. Okay, so this is we used inductive reasoning, but we came up to a false conclusion. So this is actually inductive, but also false. Okay, the last 4 answers were false. Therefore, the next answer will be false. Okay, so based on the 4 previous answers being false, the next answer will be false. That is taking specific examples, specific cases, and coming up with a general conclusion based on a pattern. That is inductive. Okay, practice makes perfect. Therefore, if I practice, I'll be perfect. That would be deductive reasoning. I actually like the phrase better though. Not that practice makes perfect, but perfect practice makes perfect. Because if you have been practicing something wrong for a long time, like let's think about a sport. Like if you did golf and you were practicing your swing wrong, even though you practice for 8 hours every day, but you were swinging wrong the whole time, you're not going to be perfect. But if you go and you practice and you do a perfect swing every single time, then you will become perfect, right? So, just a little aside. You can use the gist of what we saw in the previous examples to fill out the rest. Okay, and we're going to do a quick recap before we move on. Which kind of reasoning uses patterns? That is our inductive reasoning. Okay. Which kind of reasoning uses general statements to draw conclusions about specific examples? So going from general to specific, that is our deductive reasoning. Okay. Which kind of reasoning can only be proved false but not true? That's inductive. Which kind of reasoning looks at specific examples to draw a general conclusion? So going from specific to general, that is inductive. And which kind of reasoning can be proved true or false? That is deductive. So we're going to use some deductive reasoning to solve this logic puzzle. In a certain bank, the positions of cashier, manager, and teller are held by Brown, Jones, and Smith, though not necessarily respectively. So that means that doesn't mean that Brown's a cashier, Jones is a manager, and Smith is the teller. Okay, they tell us that the teller, who was an only child, earns the least. Okay, Smith, who married Brown's sister, so Brown has a sister, earns more than the manager. From this information, we can gather a lot about who has which position, because it tells us that the teller is an only child. So we know that it cannot be, so between Brown, Jones, and Smith, it cannot be Brown because Brown has a sister. Okay? But we also know that the teller is an only child, but also earns the least. Okay? So that's all that we know about the teller. We know that it is not Brown. The teller is an only child, and they earn the least. Then we're told that Smith, who married Brown's sister, earns more than the manager. Based on this information, we know that Smith cannot be the teller because he does not earn the least, because they earn more than the manager. And Smith cannot be the manager because he earns more than the manager. So therefore, Smith must be the cashier. From this information, we know that Smith cannot be the teller then, so that the teller must be Jones. Okay, so we know Smith is the cashier. Jones is the teller. And then by process of elimination, then that means that Brown is the manager. So from these two pieces of information, we are able to determine what position each person has. Just a quick aside, I love logic puzzles. If you are interested in doing more logic puzzles, they're really good to keep your brain sharp and they pass time. Let me know and I will send you an email with some logic puzzles that you can work on. And I'll send you some that might be easy, might be hard. Also, Sudoku is a logic puzzle. So if you like Sudoku, you like logic puzzles. Anyway, aside from that, we're going to look at the example below. We're going to predict the fourth line. What kind of reasoning are we using? So we have 1 times 9 minus 1 is 8. And remember our order of operations. Order of operations, 3 O's. You might think of that as PEMDAS. When we see these operations, we're going to follow our order of operations. So we have to do our multiplication first, then subtraction. So 1 times 9 is 9. 9 minus 1 is 8. Then they do 21 times 9 minus 1 equals 188. And then 321 times 9 minus 1 is 2,888. And then we have 4,321 times 9 minus 1 is 38,888. So based on this pattern, which kind of tells us what reasoning it is, we could guess that the next line, if I look at this, I have 1, 2, 1, 3, 2, 1, 4, 3, 2, 1. So the next one I would think would be 5, 4, 3, 2, 1. The 9 stays the same each time, and the minus 1 stays the same each time. And this pattern, if it holds true, we would assume that it would be a 4 with 5 8s afterwards. 1, 2, 3, 4, 5. Because I have 1 8. 1 followed by 2 8s, 2 followed by 3 8s, 3 followed by 4 8s, so I have a 4 followed by 5 8s. Because we used a pattern to determine that, the kind of reasoning that we're using is inductive. And by golly, if you do this calculation in your scientific calculator, you do get 488,888. How cool is that? Okay. Now, has each conclusion been proven? Explain. So we're looking at the ones that we saw before, some of the ones that we saw before. Mike, Dan, Marie, and Ange smoked and got lung cancer. Everyone who smokes gets lung cancer. No, this has not been proven. There could be people who smoked who never got lung cancer. One counterexample would prove that that's false. 47 plus 41 is 88. 31 plus 29 equals 67 plus 47 equals 54. The sum of two prime numbers is even. This has not been proven. It's also not true. One of our prime numbers that we have is 2. 2 plus any odd number will give me an odd number. So that is not true, but it's also not proven just based on these 3 examples. Okay. Remember, if it's inductive, it has not been proven true. You're just making an assumption. You're making a prediction. An even plus an odd will result in an odd number. The sum of 5,425,998 and 9,853,221 is odd. We have not proven this, okay, but it has been proven. We can prove this in general. An even number, if I were to represent it, algebraically speaking, an even number can be written as 2n, okay? So I can represent any even number as 2 times n, where n is any of the counting numbers. So n could be 1, n could be 2, n could be 3, n could be 4, n could be 1,000,000, n could be 1,000, n could be 7. Like, n could be any number. If I multiply it by 2, it gives me an even number. To represent any odd number, I can represent it as 2n minus 1. Okay? Because if n is 1, I have 2 times 1, which is 2, and 2 minus 1 is 1. 1 is odd. Okay? And if I sum those together, add them up, I end up getting 4n minus 1, which is the same thing as 2 times 2n minus 1, which is an odd number, because this is the same thing as if I called 2n m. 2 times any number is an even, minus 1 is odd. So this could be proven true. Okay, so therefore that would be true. The sum of 5,425,998 plus, okay, 9,853,221 is odd, because it's an even plus an odd. Okay, 3 is prime, 5 is prime, 7 is prime, all are prime. We already said that that is not proven. It is false. We can come up with that counterexample. 9 is odd, but it is not prime. Okay, every coach must know his sport. John Madden was a football coach. John Madden knows football well. I would say that that's proven, but that might be a matter of opinion. I don't know. Anyway, all the video games are named after him, so I would assume he knows his sport well.